Hi students, welcome to lesson number 32, Diagrammatic and Graphic Representation. Let us start with the introduction. Tabulation is one of the techniques for presentation of collected data, which makes it easier to establish trend, the pattern and comparison. It is difficult for processing and presentation of data and cumbersome task for a researcher to interpret a table having a large mass of numerical information. Sometimes it may fail to convey the message meaningfully to the readers for whom it is meant. To overcome this inconvenience, the diagrammatic and graphic representation of data has been invented to supplement and explain the tables. Practically, every day we can find the presentation of stock market index, the cost of living index, etc. in newspapers, television, magazines, magazine reports, etc. in the form of diagrams and graphs. This kind of presentation is also termed as the visual presentation or charting. In this unit, you will learn about the importance of the visual presentation of data. You will also study the different kinds of diagrams and graphs which are more popularly used for presenting the data in research work. Also, its principles on how to present the frequency distribution in the form of diagrams and graphs. Let us start with the objectives. 1. To study the need and significance of visual presentation, the diagrams and graphs of the data in the research work. 2. To examine the various types of diagrams and illustrate how to present the data through an appropriate diagram. 3. To study the principle of preparing a graph. 4. To present the frequency distribution in the form of histograms. Now, let us examine the importance of visual presentation of data. The visual presentation of statistical data has become more popular and is often used by the researcher and the statistician in analysis. The visual presentation of data means presentation of statistical data in the form of diagrams and graphs. In these days, as we now know, every research work is supported with visual presentation because of certain reasons. They relieve the dullness of the numerical data. Any list of figures becomes less comprehensible and difficult to draw conclusions from as its length increases. The scanning of the figures from tables causes undue strain on the mind. The data, when presented in the form of diagrams and graphs, gives a bird's eye view of the entire data and creates interest and leaves an impression on the mind of readers for a long period. They make comparison easy, and this is one of the prime objectives of visual presentation of data. The diagrams and graphs make quick comparison between two or more sets of data simpler, and the direction of curves brings out hidden facts and associations of the statistical data. They save time and effort. The characteristics of the statistical data through tables can be grasped only after a great strain on the mind. The diagrams and graphs reduce the strain and save a lot of time in understanding the basic characteristics of the data. They facilitate the location of various statistical measures and establish the trends. The graphs makes it possible to locate several measures of central tendency such as the median, quartiles and mode, etc. They help in establishing trends of the past performance and are useful in interpolation and extrapolation, the line of best fit, establishing correlation, etc. Thus, it helps in forecasting. They have universal applicability. It is a universal practice to present the numerical data in the form of diagrams and the graphs. In these days, it is an extensively used technique in the field of economics, the business, education, health, agriculture, etc. The diagrammatic and graphic presentation, they have become an integral part of research. In fact, nowadays it is difficult to find any research work without the visual support. The reason is that this is the most convincing and appealing way of presenting the data. Diagrammatic and graphic representation of data in journals, the magazines, television, reports, the advertisements, etc. are few examples. let us understand the diagrammatic presentation. As we know, the diagrammatic presentation is one of the techniques of visual presentation of statistical data. It is a fact that diagrams do not add new meaning to the statistical facts, but they reveal the facts of the data more quickly and clearly, because examining the figures from the tables becomes laborious and the uninteresting and also confusing. Diagrams help us to see the pattern and shape of any complex situation. Thus, the data presented through diagrams are the best way of appealing to the mind visually. Hence, diagrams are widely used in practice to display the structure of the data in the research work. Let us examine the rules for preparing the diagrams. As we have discussed earlier, the prime objective of diagrammatic presentation of data is to highlight their basic hidden facts and relationships. To ensure that the presentation of numerical data is more attractive and effective, therefore, it is essential to keep the following general rules in mind while adapting diagrams in research work. Now, let us discuss them one by one. 1. You must have noted that the diagrams must be geometrically accurate. Therefore, they should be drawn on the graphic axis, that is x axis horizontal line and y axis vertical line. However, the diagrams are generally drawn on a plain paper after considering the scale. 2. While taking the scale on x axis and y axis, you must ensure that the scale showing the values should be in multiples of 2, 5, 10, 20, 50, etc. 3. The scale should be clearly set up. Example, the millions of tons, persons in lakhs, value in thousands, etc. On y axis, the scale starts from 0 as the vertical scale is not broken. 4. Every diagram must have a concise and self-explanatory title, which may be written on the top or bottom of the diagram. 5. In order to draw the reader's attention, diagrams must be attractive and well proportioned. 6. Different colors or shades should be used to exhibit the various components of diagrams, and also an index must be provided for identification. 7. It is essential to choose a suitable type of diagram. The selection will be depend upon the number of variables, minimum and maximum values and objects. Generally, diagrams are classified on the basis of their length, width and shape. There are various types of diagrams, namely one-dimensional diagram, two-dimensional diagrams, three-dimensional diagrams, charts, pictograms, cartograms, etc. Now, let us discuss the important type of diagrams which are more frequently used in social science research in general, particularly in business research. The one-dimensional bar diagrams. Bar refers to the thick line under this type of construction. Only one dimension, that is the length, is taken into account for the purpose of comparison and observance of fluctuations in growth. The length of each bar is proportionate to magnitude of the data. The width is not related to the magnitude of the data. Generally, the width is given for the purpose of visual effect and attractiveness. The width of each bar and the gap between one bar to another bar must be uniform. Mention the respective figures at the top of every bar, particularly when the scale is too narrow, so that the reader knows the figures without consulting the scale of the diagram. The dimensional diagrams for presenting data, such as the line diagram, simple bar diagram, multiple bar diagram, subdivided bar diagram, percentage bar diagram, the deviation bar diagram, etc. The simple bar diagram. In a simple bar diagram, the data related to one variable is depicted, such as the profits, investments, exports, sales, production, etc. This type of diagram may be drawn either vertically or horizontally. Both positive and negative values can be presented. In such a case, if bars are constructed vertically, the positive values are taken on the upper side of the horizontal axis, while the negative values are taken on its lower side. On the other hand, if the bars are constructed horizontally, the positive values are taken on the right side of the vertical axis and the negative values are considered on its left side. This type of construction of bars are also called deviation bar diagram. The simple bar diagram is very easy to prepare and understand the level of fluctuations from one situation to the other. Only length is taken into account and not width. Width should be uniform for all bars and the gap between each bar is normally identical. In this type of diagram, two or more than two bars are constructed side by side for a period or related phenomena. This type of diagram is also called the compound bar or the cluster bar diagram. The technique of preparing such a diagram is the same as that of the simple bar diagram. This diagram on the one hand facilitates comparison of the values of different variables in a set, and on the other it facilitates the comparison of the values of the same variable over a period of time or the phenomena. To facilitate easy comparison, the different bars of a set may be colored or shaded differently to distinguish industries or the profit loss, diagrammatic and graphic representation between them. In this diagram, one bar is constructed for the total value of the different components of the same variable. Further, it is subdivided in proportion to the values of various components of that variable. Such bars shows the total of the variables as well as the total of its various components in a single bar. Hence, it is clear that the subdivided bar serves the same purpose as multiple bars. The only difference is that in case of multiple bar, each component of a variable is shown side by side, whereas in construction of subdivided bar diagram, each component of a variable is shown one upon the other. It is also called a component bar diagram. This method is suitable if the total values of the variables are small. Otherwise, the scale becomes very narrow to depict the data. To study the relative changes, all components may be converted into percentages and drawn as subdivided bars. Such a bar construction is called a subdivided percentage bar. The limitation is that all the parts do not have a common base to enable us to compare accurately the various components of a set. Let us examine the pie diagram. The pie diagram are generally used to show percent breakdowns. For instance, we can show how the budget is allocated under different heads. A pie diagram is a subdivided circle. The area of different divisions in pie diagrams are in the proportion of the data to be presented. While making comparison, the pie diagram should be used on a percentage basis and not on an absolute basis. In constructing a pie diagram, the first step is to convert the various values of the components of variable into the percentages and then the percentages transposed into the corresponding degrees. The total percentage of the various components, that is 100, is taken as 360 degrees, the degrees around the center of a circle, and the degree of the various components are calculated in proportion to the percentage values of different components. It is expressed as the components percentage 100, 300 degrees x. It should be noted that in case the data comprises of more than one variable, to show the two-dimensional effect for making comparison among the variables, we have to obtain the square root of the total each variable. These square root, diagrammatic and graphic presentation 37 roots would represent the radius of the circles and then they will be subdivided. A pie diagram helps us in emphasizing the area and ascertaining the relationship between the various components as well as among the variables. However, compared to a bar diagram, a pie diagram is less effective for accurate interpretation when the components are in large numbers. There are several important diagram formats that are used to display the structural information, that is the qualitative, in the form of charts. The format depends upon the nature of information. Under these type of diagrams, we will now discuss two different diagrams, the organizational charts and the flow charts. One, the organizational charts. These types of charts are most commonly used to represent the internal structure of the organizations. There is no standard format for these kinds of diagrams, as the design of the diagram depends upon the nature of the organization. The graphic presentation. Everybody, irrespective of whether he or she is a layman or an expert, has a natural fascination for appropriate graphical presentation of data, which remains an essential part of research methodology. The graphic presentation of data leaves an impact on the mind of the readers, as a result of which it is easier to draw trends from the statistical data. The shape of a graph offers easy and appropriate answers to several questions, such as the direction of curves on the graph makes it very easy to draw comparisons. The presentation of time series data on a graph makes it possible to interpolate or extrapolate the values, which helps in forecasting. The graph of frequency distribution helps us to determine the values of mode, median, quartiles, percentiles, etc. The shape of the graph helps in demonstrating the degree of inequality and direction of correlation. For all such advantages, it is necessary for a researcher to have an understanding of different types of graphic presentation of data. In practice, there are a variety of graphs which can be used to depict the data. Broadly, the graphs of statistical data may be classified into two types. One is the graphs of time series, another is graphs of frequency distribution. The foremost requirement of a researcher is to be aware of the basic principles for using the graph paper for presentation of the statistical data graphically. Conventionally, graphs are drawn on a graph paper. Two perpendiculars are drawn which intersect each other at right angles. This intersecting point is called the origin point or the 0 point. The horizontal line is known as x-axis, the ordinate on which independent variables are shown, while the vertical line as y-axis, abscissa, on which the dependent variables are shown. The graph paper is subdivided into 4 parts termed as the quadrants. These quadrants are meant to depict the positive values and the negative values of x variable and the y variable. Now, let us look into the graphs of time series. A time series is a set of values of a variable or the variables arranged over a period of time. For example, the data relating to the production, sales expenditure, exports, etc. during the last 10 years. Thus, a graph of time series is prepared to show the values of one or more than one variables over a period of time. This type of graphs are also termed as the time graphs or the histograms. Because history is represented graphically, these graphs are helpful in studying the changes over a period of time and forecasting. Histograms can be constructed in two ways: on a natural scale, arithmetic scale, and on a ratio scale. The natural scale graph reflects the changes in the absolute values over a period of time, whereas the ratio scale graph reflects the relative changes over a period of time. Now, the construction of histograms and the natural scale. Natural scale graphs are used to show the absolute values on relative values in terms of percentages, such as the index numbers of time series. The following principles should be kept in mind while constructing the histogram, so that the reader should not have to search through the text in order to understand a graph. 1. On x axis, we take the time as independent variable, and on y axis the values of data are dependent variable. Now, plot the different points corresponding to given data. Then the points are joined by a straight line in order of time. 2. The equal magnitude of scale must be maintained on x axis as well as on y axis. 3. The y axis normally starts with the 0. In case there is a wide difference between the lowest value of the data and the 0, the origin point, the y axis can be broken and a false baseline may be drawn. The quadrant 2, quadrant 1, quadrant 3, quadrant 4 x negative values, y positive values. If the variables are in different units, double scales can be taken on the y axis. The scales adopted should be clearly indicated and the graph must have a self-explanatory title. Unfortunately, the graphs lend themselves to considerable misuse. The same data can be given different graphical shapes depending on the relative size of two axes. In order to avoid such misrepresentations, the convention in research is to construct graphs wherever possible such that the vertical axis is around 2 by 3 to 3 by 4 the length of the horizontal. After having learnt about the principles for the construction of the histograms, there are various types which have been developed. Among them, the frequently used graphs are one dependent variable graphs and more than one dependent variable graphs. The graphs of one dependent variable when there is only one dependent variable. The values of the dependent variables are taken on y axis, while the time is taken on x axis. The frequency distribution can also be presented in the form of graphs, such as such graphs give a better understanding and provide illustrative information to the readers than the data in the tabular form. It is true that effective graphs can markedly increase a reader's comprehension of complex data sets. Compared to the tables, the graphs of frequency distribution are helpful in identifying the characteristics and the relationship of the data. These graphs are also useful in locating the positional averages such as mode, median and quartiles, etc. In a continuous frequency distribution, the class limits or the mid values are taken on x axis and the frequency on the y axis. The vertical axis x, the y axis is not broken. Thus, the false baseline cannot be taken. A frequency distribution can be portrayed by means of histogram, the frequency polygon, the ogive curves and the scatter diagram. Let us study the procedure involved in the preparation of these type of graphs. The histogram and the frequency polygon histogram. The graph usually drawn to represent a frequency distribution is called a histogram. A histogram is a set of rectangles, the vertical bars, each proportionate in width to the magnitude of a class interval and proportionate in area to the number of frequencies concerning the classes and the intervals. In a histogram, the variables, the class intervals are always shown on x axis and the frequencies are taken on the y axis. In constructing a histogram, there should be a diagrammatic and graphic representation, not be any gap between two successive rectangles, and the data must be in exclusive form of classes. However, we cannot construct a histogram for distribution with open end classes and it can be quite misleading if the distribution has unequal class intervals. The value of mode can be determined from the histogram. The procedure for locating the mode is to draw a straight line on the top of the right corner of the highest rectangle, the model class, to the top right of the corner of the preceding rectangle, the pre-model class. Similarly, draw a straight line from the top left corner of the highest rectangle to the top left corner of the succeeding rectangle, the post-model class. Draw a perpendicular form the point of the intersection of these two straight lines to x axis. The point where it meets the x axis gives the value of the mode. However, graphic representation location of mode is not possible in a multi-distribution. The frequency polygon. Polygon means many angle diagram. This is another way of depicting a frequency distribution graphically. It facilitates comparison of two or more frequency distributions. Frequency polygon can be drawn either from the histogram or from the given data directly. The procedure for the construction of a frequency polygon by histogram is to first draw the histogram. As explained earlier, of the given data, Then put a dot at the midpoint of the top horizontal line of each rectangle bar and join the dots by straight lines. Another way of drawing frequency polygon is to obtain the mid values of class intervals and plot them on x axis. Mark frequency along the y axis. Then plot the frequency values corresponding to each midpoint and connect them through the straight lines. The area left out is just equal to the area included in it. Hence, the area of polygon is equal to the area of histogram. The difference between the histogram and the polygon is that the histogram depicts the frequency of each class separately, whereas the polygon does it collectively. The histogram is usually associated with the data of discrete series, while frequency polygon is continuous series data. The cumulative frequency curves. Sometimes we are interested in knowing how many families are there in a city whose earnings are less than 5,000 per month or whose earnings are more than 20,000 per month. In order to obtain this information, we have first of all to convert the ordinary frequency table into the cumulative frequency table. When the frequencies are added, they are called cumulative frequencies. The curves so obtained from the cumulative frequencies are called the cumulative frequency curves, popularly known as the ogives. There are two types of ogives, namely less than ogive and more than ogive. The procedure involved in drawing these two ogives. In less than ogive, we start with the upper limit of each class and the cumulative in addition starts from the top. When these frequencies are plotted, we get less than ogive. In case of more than ogive, we start with the lower limit of each class and the cumulation starts from the bottom. Then these frequencies are plotted, we get more than ogive. You should bear in mind that while drawing the ogives, the classes must be in exclusive form. The ogives are useful to determine the number of items above or below a given value. It is also useful for comparison between two or more frequency distributions and to determine certain values, that is the positional values such as the mode, median, quartiles, percentiles, etc. Let us sum up. The statistical data not only requires a careful analysis, but also ensures an attractive communicative display. The work of the researcher is to understand the facts of the data himself or herself and also to present them in such a form that their significance may be understandable to common reader. In order to achieve this objective, we have in this unit discussed the techniques of diagrammatic and the graphic presentation of statistical data. Besides presenting the data in the form of tables, data can also be presented in the form of diagrams and the graphs. Such visual presentation of data allows relation between the numbers to be exhibited clearly and attractively, makes quick comparison between two or more data sets easier, brings out the hidden facts and the nature of relationship, save time and effort. Effort facilitates the determination of various statistical measures such as the mean, mode, median and quartiles, the standard deviation, etc., and establishes trends of past performance. Hence, with the help of the diagrams and the graphs, the researcher can effectively communicate to the readers the information contained in a large mass of numerical data. Thank you.